right, thank you, Peter. Yeah, it's true, I got to go to Bill Gates' house, but it wasn't like just me and Bill G hanging out having coffee, unfortunately. That would have been awesome. He did this thing where he'd have all the interns at Microsoft come over to his house. It'd be like 300 interns, and we'd just like go and walk through this giant house. It was amazing. I actually have a lot of stories from that day. We can talk about it later. But it was a lot of fun. I guess he stopped doing that a couple years after I interned, so I was so glad I got to do that. But anyway, my name's Bryan Phelps. I guess that's a good segue into my talk, making Windows reasonable. There's actually a few things I want to talk to you about today. First, a quick intro for those who don't know me. I'm the founder of a company called Outrun Labs. And Native Reason is what I think, at least hope, is our secret sauce. Previously, I worked at Microsoft, and that kind of explains why making things work on Windows is important to me. And even though it might not look like it from my MacBook, the Microsoft influence still lives on, and I'm primarily a Windows developer. You can find me on Twitter, GitHub, Discord as Bright. And so there's a few things I want to talk about today. First, I want to share with you why I'm so excited about Reason, and especially Native Reason. Second, I want to talk about making the easy tool work on Windows and some of the hurdles and challenges that we faced. And finally, I want to share with you the way we're using this Native Reason tech to build and ship cross-platform apps. So let's dive in to why Native Reason. And for that, I'd like to share this quote with you. This quote is from a famous graphics programmer. His name's Michael Abrash, and it's from a book he wrote called the Graphics Programming Black Book. And it's actually freely available on GitHub. I have a link in my slides here. And I highly recommend it. Even if you're not interested in graphics, it's a really fun read and kind of has generally applicable lessons. But here's a quote. Is performance still an issue in this era of cheap 486 computers as super fast Pentium computers? You bet. How many programs that you use today really run so fast that you wouldn't be happier if they ran faster? We're so used to slow software that when a compiled link sequence that took 2 minutes on a PC takes just 10 seconds on a 486 computer, we're ecstatic. When in truth, we should be settling for nothing less than instantaneous response. Yeah. What's crazy about this quote, though, is it's from 20 years ago. And in that time, our processors have gotten hundreds of times faster. Our memory and disks have gotten faster. We've got SSDs and flash drives. We're still struggling with this same exact challenge. And I would argue that, at least subjectively to me, my PC doesn't really feel any faster than it did 10 years ago. In fact, I think sometimes it feels slower. It's normal for apps to take 5, 10, 20 seconds to start up. And when we think about performance, it's worth looking at how we build our applications. The most popular tool today for building a cross-platform desktop application is Electron. And it's popular for good reason. It's never been easier for a small team to build and ship a cross-platform application. Its strength is that it allows you to develop cross-platform with confidence. What I mean by that is you can write your code, you can test it on one platform, and you can be 99% sure it's going to work and look consistent everywhere. And that's really powerful. Not only that, you can bring to bear the full web development ecosystem. And tools like React mean it's never been easier to build UI. And if you're not familiar with Electron, it's basically bundling up Chromium and Node into a package where you can run a JavaScript app. Of course, those aren't the only pieces. You're always going to have platform APIs underneath, things like OpenGL, Vulkan, Metal, sometimes libraries like HarfBuzz or FreeType to help you with text rendering, and those are used by Chromium. And above Node and Chromium, you'll have all your NPM modules. And if you're using React, of course React.js is going to be there too. It's not uncommon to have thousands of these dependencies. And at the very top, you have your application code. It's a lot of layers, and we do get something for it, in the sense that Electron has made it easier than ever to build cross-platform applications. But these layers and abstractions, they come at a cost. Part of that is a performance cost, a build time cost, and sometimes a complexity cost. Not only do you have to be aware of your application layer, the code at the very top, but ultimately, you're responsible for everything underneath too. But the fact is, there just isn't a great alternative today, especially not if you want to develop your applications in a functional React style. What if we could streamline? What if we could go Conda Maria on our stack and just take out a bunch of pieces, remove the JavaScript, the Node, the Chromium, and replace it with something that could compile to native code? Replace our NPM modules with smaller, more streamlined set of compiled to native dependencies. What would that look like? This is where we could get our performance back. And I think that Reason and Reason Native gives us the tools to get there. With Reason, it's like we have a language purpose-built for this idea of React, a functional UI. Your UI expressed as a pure function of state. This is a paradigm that's been battle-tested in the fierce, ever-evolving arena of web frameworks. And now, we have a language that feels like it was built from the ground up for it. And it compiles to native code. When you compare ReasonML to something like TypeScript, in my mind, this is one of the key strengths, the differentiator, because you have the ability to not only work on the web, but you have the ability to compile to streamlined native code as well. I think there's so much untapped potential there. On top of that, it's not like native Reason is happening from scratch. We're leveraging all the great investments companies like Jane Street, OCaml Labs are pouring into the OCaml compiler. We get things like PPX to streamline our syntax, FLambda, an optimizing compiler, and eventually multi-core. And so really, in a sense, we're benefiting from all that sweat and hard work and repackaging it so we can make it easier for developers coming from JavaScript and React to leverage it. So now I want to dive more into building that idea of building cross-platform with confidence and how that's happening with Reason Native. So let's talk about easy on Windows. A first question, natural question might be, why Windows in the first place? And can I see a show of hands, like how many people along with me are primarily Windows developers? That's like 3.5 hands? Cool, out of maybe, I don't know, 100 people? So it's a pretty fair question to ask. Well, number one, I think like Windows is a huge market of developers. This is from the latest Stack Overflow developer survey. And Windows is just a huge population of professional developers. And it's obviously like kind of an underrepresented set of users in our conference and our community. And it's really kind of a chicken and the egg problem, because if we don't have the tooling or seamless experience in place for Windows developers, how are we going to get more Windows developers here to help us improve the tooling and get that better experience? So Jordan talked a little bit about easy. And to be able to work cross-platform, you need something that can help you install dependencies, build, and run everywhere. And this is something Node and Electron does so well. I can grab a Node app or an Electron app, npm install and npm build, and it usually just works everywhere. And with easy, we have this. We have this easy package management for native Reason, OCaml, and more. Easy is a source package manager, which means it builds from source code. This is nice because you can kind of audit the sources you're building instead of getting black box libraries. It also adds some complexity. The package manager has to figure out when does it need to recompile from these sources. It turns out it's not just a function of the source code. Sometimes environment variables or other factors can affect that build output. Easy's built in Reason and OCaml, and it leverages the OCaml package manager, both in the code and the protocol. It also works well with NPM, GitHub, local links. And the local links are really nice for if you're developing something and you have packages kind of all over the place. you can make changes to a package and test that it works correctly in another app that's dependent on the package. I think the easiest way to think about easy is like NPM, but for native code. And as Jordan mentioned in his slide, Andre Pop is the primary developer and has just done a ton of work with it to help enable this scenario. So I'm going to show a quick demo of running easy on Windows. And I've git cloned this Hello Reason project, which is just a really simple starter project for Reason, native Reason. Using easy is a lot like using NPM. Instead of NPM install, I use easy install. Instead of easy build, instead of NPM build, I use easy build. Now the first time you build, it's not going to be this fast. I'd actually built ahead of time. And easy is smart enough to cache sort of the output from all the dependencies. This easyx command says run this command as if it were installed. So the build command produced this hello executable, and I ran easyx hello, and it runs a program. So I can see that everything works. And this is a Windows shell. So I have my cross-platform story, at least on Windows. And easy uses a familiar format, a package.json. And this is the package.json for the Hello Reason project. And it's pretty familiar if you're coming from the NPM world. There's just a special easy block. And we also have dependencies coming from other places. Like we have some coming from the OCaml package manager. So Dude, Merlin, ODoc are all coming from OPAM, the OCaml package manager. But getting easy to work on Windows wasn't always this seamless. There were a bunch of challenges on the way that we had to solve to get this cross-platform experience. It's really two categories of issues. The first were ecosystem challenges, challenges that were specific to the OCaml ecosystem. And the main issue we faced is that a lot of these packages, OCaml packages, depend on bash utilities, bashisms, or like POSIX utilities being around. Things like make or grep. Then there was another category of issues, just general issues you hit whenever you do cross-platform development. That's things like line endings, path differences. There's good news though. The OCaml compiler builds and works great on Windows, so at least that foundation was there for us. And there's a build tool for native Reason and OCaml called Dune, and that's quickly becoming the standard. It actually gets rid of a lot of these problems. The problem is, it just isn't everywhere yet. So these were some of the dependencies that the OCaml packages needed, like things like make, sed, grep, awk, things we just expect to have around in our command prompt, but aren't there on Windows. Then easy also used its own set of utilities like tar, curl, for downloading packages or unpacking them. And if we were going to have to solve this problem for the OCaml package manager packages, we might as well solve it for easy too. The first solution we looked at that seemed like it'd be a perfect fit for this was to use this new feature of Windows called the Windows Subsystem for Linux, or WSL. And this is a new feature where you can essentially host a Linux distro right on your Windows machine. This sounds like a perfect fit for what we were trying to do. But the problem was, at least when we investigated this, there was no one-click install, meaning we wouldn't have like a really streamlined experience to install easy on Windows. We need to have manual steps for users to not only enable WSL, but to pick out a distro, set that up. Then every distro has its own package manager, so you'd have to install the dependencies specific to that distribution. We thought that was too much of a hurdle to get in the way of that one-click experience. The other option we looked at was a project called Cygwin. Has anyone used Cygwin here? Oh, okay. A lot more than the Windows developers. It's interesting. Cygwin has been around for a long time, and it's pretty mature. And today, if you want to use OCaml packages on Windows, Cygwin's really the happy path. It's sort of the blessed way to get the OCaml package manager working on Windows. It provides a POSIX environment. It has these MingW cross compilers that let us have Windows native binaries. So we can produce binaries that have no dependency on Cygwin. And importantly, for like the one-click install story, we could deliver it in a silent, unintended install. And the most important thing is that we were able to produce these native Windows executables. We didn't want to ship executables that depended on Cygwin. So what you get out of it, like with that Hello Reason project, is an executable that you can just send out and it'll work on a Windows machine. So to facilitate this, we created an NPM package called EasyBash. And this is really just a thin wrapper around Cygwin and around Bash that's bundled with Cygwin. It actually works from the CLI or via an API. You can send it commands and pretend you're in a Bash environment. I'll show a quick demo of what that looks like on Windows. So here I have npm install g'd EasyBash, so I have it available. Let's see if it'll start. All right, there we go. So with the CLI app, I can just pass an argument that'll run as if it's in Bash, essentially. So I'll have make here. Oh, yeah. I could do things like ls at the root, and I'm actually looking at the root of the Cygwin sandbox. It actually looks a lot like Linux, except for all these Cygwin extras there. I can do other things like I have grep around, which is great. I can also just like call into Bash directly. So that's not very interesting, but I could also just call Bash and switch my Windows shell over to a Bash shell. And the way that works with Easy is Easy actually bundles it as a dependency. So all the build commands that it makes actually go through that Easy Bash layer. So it's sort of this transparent layer where Easy can issue commands and know it's just going to work whether it's Windows or Linux or Mac. Then another issue we hit were line endings, these carriage return line feed issue. And line endings cross-platform are kind of a mess. And this is really to blame for it. See, before we had all these nice retina displays and screens, there'd actually be a physical printout. Your terminal would actually print the output. Crazy to think about. And going to the next line with a printer is actually a two-part maneuver. So one part is the carriage return, is actually a horizontal motion of moving the print head back to the left of the page. The other part is a line feed, and that's advancing the paper up, and that's a vertical motion. So when you press the return key on your keyboard, both of those things would have to happen. Now it turns out it was actually important to separate these because the printers would use some tricks. If you wanted to have bold text in your printout, it turns out the teletype didn't have bold ink or anything like that. What would happen is you'd issue a carriage return, then you just print over the words you want to be bold again, and they'd look a little darker. And it worked. But on Multics and Unix machines and Linux, they realized it didn't really make sense to have just a line feed by itself. If you're going to feed the page up, you probably want the print head to go back to the start of the line. So they kind of helped us out, and in the driver they abstracted this. If you give a line feed, they're just going to assume you meant a carriage return and a line feed. So Linux today, Mac, they all assume that you're going to use a line feed as your line ending. DOS and Windows though, there's no driver abstraction. They want you to be very specific about how you're ending your line. So on Windows today, we have these two characters, a carriage return and a line feed. There are actually some other machines that are older that decided carriage return made sense for the line ending, so we sort of had all the possibilities there. But today we really just have to worry about line feeds and carriage return line feeds. Another issue we ran into is that Windows uses the backslash as its path separator. This also happens to be the escape character. So you can run into this problem where you have a path that looks fine on Windows, but you save it to a file, and you read it back, and then there's something different about it. It doesn't work. And if you're not careful, this can kind of pop up. At least it's easy to see when you look at your build logs. You can realize pretty quickly what's happening. But we fix this in easy by just switching to use the /. And it turns out Windows handles that too. Then there were a few other issues that we hit, things like path length limits, environment size limits, issues with symlinks, command length limits, but easy works on Windows now. And we have that one-click install story. We have that ability to set up and run projects on all platforms. And I think this is really powerful because it's the first step to developing cross-platform with confidence, like we do with Node, Electron, and NPM. On top of that, if you couple it with all the great work that's happening, like Rely, like the Azure CI configs that we have, you can actually run your continuous integration cross-platform. And you can enjoy that warm, fuzzy feeling of knowing that at least the code that you test that's running in these different places, at least those parts work. So having that tooling is really the beginning of the story, not the end. I want to share with you a few projects that myself and collaborators are working on. The first being Revery. Revery is a UI and application framework. Features React-like concepts. It compiles to native code, but it can also compile to JavaScript. It's desktop only for now. We'd love to have mobile builds. And it features a platform-agnostic UI. And that's really a trade-off. It means that we render the UI exactly the same on every platform. This is great for some use cases. For the case where you want to build cross-platform with confidence because you know it'll look exactly the same everywhere. So I can test on my Windows machine, and it should look the same in other places. But it's not always the right trade-off. Sometimes you want to use the platform UI. There's another cool project in the community called Brisk that is sort of like Revery, but for platform-specific UI. And the team that built this project created another project called Brisk Reconciler, which is our native React implementation. And to show you some code, this is the simplest, smallest Revery app. It simply opens a window and renders an empty view. This app.start at the bottom is the entry point, and it takes a function that's handed an app object, and you can use that app object to create an application window. And this UI start, you can think of it a lot like React DOM render. And we have a component model too. And I'm actually showing you kind of a intricate, complicated component here. This is a component that renders a view that has two hooks, a state hook and an effect hook. And the way hooks work in Revery is the components pass the hook's object, and then each time it uses a hook, you pass that hook's object in, and it returns you a new hooks object. So here we have the hooks.state, where I'm setting an initial state of 1, and I'm passing in the hooks object. And I'm getting my state and set state like I'd expect from React, but I'm also getting back one more thing, that hooks. Then I have an effect that's going to print when the component's mounted and unmounted. It's the same thing. I pass the hooks at the end, and I get a new one back. And at the very end, I pass back a tuple of my hooks and the JSX component. And it might seem like a lot of boilerplate coming from React.js, but it does give us something. We actually have type safety with hooks. When you work with React.js, you have to be very careful to follow the rules of hooks. Otherwise, you might get unpredictable behavior, errors in the console, crashes. With this, the compiler can actually validate for us that our hooks are structured correctly. We're actually using the hooks kind of like a baton, like passing it from hook to hook and tagging it with some type information at each point. At the very end, we can validate that all of the paths taken are consistent and that everything is good. And this really resonates with the ideas of like reason-conf that if it compiles, it should work. So I'll show a quick demo of the native app. So again, this is Windows. I'm back in my Revery project, and I'm just going to easy install, easy build. And Jordan mentioned there's actually a shortcut. you can use easy to combine both those steps. Then I used easy run to start up the app. And this is our example app in the repo. So the very first example shows some animation. One of my favorite examples that we have here is the calculator, because it actually shows something non-trivial that has to do some state management and some user input. So it works. It's like you'd expect a calculator to. Not only that, though, is you can compile the same exact app in JavaScript and WebGL. So I'll show that. And in the spirit of being cross-platform, I decided to switch to Mac for this demo. So this actually uses another feature of Easy called a sandbox, where you can have I have a JS sandbox set up. It's just a js.json file that has some custom dependencies for JavaScript and some extra scripts to help me bundle up like an index.html, some of the extras I need to have a JavaScript app. And I have a custom script for run that helps me start up that server. So I'm going to copy the URL and see what it looks like. It's the exact same app. So it really works just like the native app. But Revery isn't done. There's still a lot of things on my mind that we need to do. And this, I laid it out like a timeline, but it's not really a timeline. It's just sort of the next steps that I see in no particular order. The first is a component model simplification. I'd like to reduce the boilerplate of passing that hooks object around, get that same type safety, but in a more concise syntax. We're working on integrating a graphics library called Skia, which would give us great vector graphics and text rendering support, and really level up the look and feel of Revery applications. And that library is used by Skia, or Sublime Text, Flutter, Chrome, so it's been used all over the place, and it's very battle tested. It would also give us a native canvas element, which would be really cool and open up a lot of interesting possibilities. Custom layout. Today, our main layout primitive is flex, but we'd like to be able to model other sorts of layout systems too. And the sort of vision I have in mind is a lot of times you see like sort of a radial UI or like radial buttons. I'd like to be able to have a layout system that can model that. Native integration is really important for us. So having text input that integrates with native fields. It's really hard to emulate it cross-platform because every platform has different ideas of how you select text or what sort of interactions you can have with a text box. And accessibility is another big part of native integration. Developer experience, performance traces, debugging, REPL support, live reloading, time travel, all these great things we have in the React.js world that we don't have it all here yet. Then mobile support. I just want to be able to say like easy at iOS run and have it just run on my iOS device or Android. And I think we can get there. One thing that's kind of fun with Revery is that we get the opportunity to revisit our assumptions. Like when we worked with React.js, we're tied to the browser's document object model. Like we know our primitives are like div, span, or other tags. But with this sort of project, we get to kind of explore and think about what's the basic unit of UI? What's the basic atom? And Revery was built from the ground up for a code editor, Onivim 2. And this started as an Electron project. The goal was to be a hybrid of Vim and modern code editors like Visual Studio Code, Atom, Sublime Text, kind of merge those worlds together. We got pretty far with it, but we ended up running into several performance issues. And around the time I was figuring out what to do next with the project, I learned about Reason. I realized Reason Native could be the perfect technology platform to build a V2 and really deliver something solid for this vision. So we got a new logo, and we went to work. We re-architected we decided to build our front end in Native Reason. But another thing happened too. VS Code is just so popular. There's so many great extensions for it. It works so well out of the box. We really wanted to be able to leverage that aspect too. So we have a back end that is essentially the back half of VS Code, their extension host. And ultimately, we'd like to support VS Code themes, source control integration, tasks, debugging, and of course, language support, and have that just work out of the box like it does for VS Code. And that works in development right now. This is what the timeline for Onivim looked like. We started prototyping the V2 early this year, worked on some stuff for Revery to sort of lay the foundation, started the development in earnest in March, and we had our pre-alpha release in July. And the pre-alpha was really big for us because we shipped binaries on Windows, Linux, and Mac. And just like packaging applications up on a new application, a new technology stack, that was a big win. Even though there were some bumps in the road, we ended up solving a lot of problems around packaging and distribution that we pushed back to Revery. And now we're working on our alpha release, which is that integration with the VS Code extension host. So I'll show a quick demo of where we're at with our current master build. And so I'm going to show just the startup a few times. I'm going to start it up and close, and then I'm just going to kind of mess around with it. But in the middle of this, I'm going to start up our V1. So see if you can spot the difference of our V2 versus our V1. So it turns out it's pretty easy to quit Vim. I don't know why everyone's so worried about that. All right, I'm going to start V1 now. So notice it kind of goes through these like sequences and then things kind of pop in. It's a little bit more jarring. It actually takes about 5 seconds for our V1 to start up, less than a half second for our V2 to start up. That's pretty incredible. It's like a 10x performance improvement. And it might not bother some people, but sometimes it gets in the way of your work. You're like, I just want to like write some code. I don't want to wait around, or I have this thought in my head. Why should I wait for my tools? And I just want to show we have some non-trivial UI. Like you can build stuff like this with Revery today. We have this mini map that is interactive with the mouse. I'm going to turn on this feature called key displayer because Vim is very keyboard driven, so you can see what I'm typing. So this percent lets you jump to a matching brace. Then I'm going to open a split. So one of my favorite features about Vim is how easy it is to create splits and navigate between them with the keyboard. So I created this horizontal split. Now I'm just moving my cursor between them with this Control-WJ, Control-WK shortcut. And I'm opening up our editor surface file. This is one of the meatiest parts of our Onivim code base because it handles all the rendering for this editor surface, like how we draw the tokens, how we color them, how we draw the mini-map. And it's kind of hard to see, so I'm going to flip into Zen mode, which focuses just the buffer that you're working on. And this was actually contributed by the community. And we have some other UI, like there's this active indent guide that updates real time. And one thing we just added is the VS Code theme support. So these are themes that are bundled with VS Code, so I'm going to switch over to one. So it's sort of a baby step into supporting kind of the fuller extent of VS Code extensions. And we're still missing a lot. There's lots of functionality missing, lots of features that we need to implement, lots of work ahead. But what I'm really excited about is the foundation that we have. The fact that we can build and ship a Reason native application, and that we've already seen tremendous benefit in our performance with this new stack. I think that's a huge win. Really, now it's all about delivering the features and functionality on top of it. And we're building Onivim 2 in the open. We have this model where we're sort of raising the price as we go. So if you're interested in helping to support us building the editor, supporting projects like Revery, you can do that by pre-ordering. The Reason community has been incredibly supportive of this and Revery, so thank you so much for your support. I actually have lots of people to thank. I had trouble making the slide because so many people have helped me with all of these projects. So I'm sorry if someone's on there, or I missed someone there. But I'm tremendously appreciative of the community and all the support we've had. It's tough being an early adopter of a new language. We're sort of all pioneers together, exploring this Wild West, this new frontier. That's all I have. Thanks for listening, being here.